All right, so I wanted to take a look at this Atwood's machine problem. That's what this is called. Now, again, step one, let's draw a free body diagram of the situation. So I'm going to have the free body diagram for M1. There's a tension going up. And there's the weight on 1 due to the Earth. And then for the second mass, there is also the tension on this mass. And there's a weight of mass 2 due to the Earth. Now let's be clear. We need to define a sign convention, what we mean by positive and negative. And in this case, M2 is in fact larger than M1. So this system is going to actually rotate clockwise. So what that means is that for W2, this will be considered clockwise motion and positive. And for mass 1, this will be considered positive motion. And that actually affects how we set up our equations. So what we're going to do is this. I'm going to set up equations for each mass. So for mass number 1, the equation is going to be T, the tension, pulling up, minus M1 times G. And that's going to equal M1, a given, times the acceleration. And we can set up a similar equation for mass number 2. We can say that there is, now let's be clear, for mass number 2, downwards is the positive direction because that's the direction in which the mass moves counterclockwise and in the positive direction. So what that tells us is that we have M2G fighting the tension pulling upwards against the positive direction. And the effect is that M2 accelerates. So now here's what I'm going to do. I'm going to isolate tension in equation 2 and rewrite the equation as T equals M2G minus M2 times A. And I'll call this equation 3. So what I'm going to do now is I'm going to combine equation 1 and 3. So when I actually do that, I will end up getting here M2G minus M2A equals M1 times A. And actually, let me be a little bit more careful. M2G minus M2A. So that's the tension. And I substituted that in there because of equation 3. And let me continue with equation 1 minus M1G equals M1 times A. Now I'm going to isolate A. So all of this equation here is equation 1, just so you know. So now I'm going to isolate A. When I do that, I'm going to actually end up getting M2G minus M1G equals M1A plus M2 times A. And finally, when I isolate the acceleration, I'm going to end up getting that the acceleration equals M2 minus M1 times G all over m1 plus m2. And then when you want to go ahead and substitute and solve for tension, so I'll call this equation 4. You can take equation 4 and plug it into, say, equation 3 and solve. And I'll actually let you go ahead and do that. It ends up being not the nicest expression. I think it ends up being like 2m2m1 over m1 plus m2 or something ridiculous like that. So I will actually let you work with that equation and simplify yourselves. So that's it for question number 4.